Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, we say our thanks to Allah subhanahu wa ta'ala and all gratitude to Allah subhanahu wa ta'ala for allowing us to meet again and continue our discussion on Allah's greatness in His creations, especially in His creation of this our beloved earth, right, where we stand and we live on it. We are approaching the end of this series of lecture. I plan to have another 3 more lectures, including tonight, before we wrap up this, cosmic creation series of lectures, because we are already towards the end of the last chapter of my book, and it is just very nicely coincidental with towards the end of this year 2021. So inshallah, we're going to end everything and wrap up our discussion of the book by the last Monday of December, inshallah, on the 27th of December. So tonight we're going to talk about on the rarity of this planet Earth and how a planet like Earth can be found, or what are the factors that affect the existence of planets like Earth. And this will, inshallah, instill in us a greater appreciation of this planet of ours. Now, science fiction stories, astronomers, right? These people, and layman people on the street, we always want to find another planet that is similar to us. The stuff of science fiction stories that we travel across space, and then humans will find another planet, and then we land on a planet, and they build another civilization on that planet, and so then they will populate the planets across the galaxies. Now, it is simple to say that, to write about it, but what are the factors that will determine the existence or the creation of a planet such as Earth? This is what we're going to explore tonight and also next week, inshallah. Now, first of all, we have to understand the term exoplanet. What is an exoplanet? An exoplanet is a term given by any planet that orbits around a star. So by that definition, our Earth is also an exoplanet, okay? Because we orbit around a star, which we call a sun. And therefore, our solar system consists of 8 exoplanets minus Pluto, because Pluto is now not considered as a planet. It's called a planetoid. Astronomers now are in consensus that Pluto does not came from the same, original substances that caused the creation, or that were the basis of the creation of all the planets that we have in the solar system. So Pluto, right, it's been agreed upon all astronomers that Pluto is a solid body far flung out into space, right, in a region that astronomers call as the Oort cloud. And somehow rather this huge body being captured by the sun, and therefore it became one of sun's children that orbits around it. And so Pluto is not originally from the series of planets that came from the existence of the sun itself. So we have 8 exoplanets. Now, how many stars are there in our galaxy? It's been estimated, and it's a very, very rough estimation. We do not know actual number. Of course, we will never know the actual number. It might be more, most probably more than that, because 400 billion stars, that this estimate has been given, 400 billion stars in our galaxy, is a very conservative estimate. Certainly it's more than that. Previously, I remember that astronomers estimated that the number of stars in our galaxy, which is called the Milky Way galaxy, is around 100 billion stars. Okay, not 100 million, 100 billion stars. So it is 1 followed by 9 zeros. Imagine that. But now they've revised it and they put it as 400 billion stars in our galaxy. Now that's a very huge number. If just one of those 1% of the billions of stars in our galaxy has exoplanets, just 1% of all these stars have exoplanets. Now that is equivalent to 40 billion planets. Imagine just 1% of 400 billion stars, and each one of them has just one planet orbiting around it. So therefore, there are 40 billion planets in our galaxy. Now, there are, again, a very rough estimate, a very low number estimation. There are at least 100 billion stars in, 100 billion galaxies in our vast universe. 100 billion galaxies. Now you multiply 100 billion, right, with that 40 billion, you get a huge number. But let's say that not all of those 100 billion galaxies have stars that has planets. Let's say, for example, for the sake of, creating a picture, or, we call it a experimental mind thought. Okay, let's say for the sake of discussion, right, only 1% of those 100 billion galaxies has stars that have exoplanets orbiting around it. And each one of those 1% of those galaxies have just 1% of the stars with exoplanets. And so therefore, if you multiply that 40 times 1% of the galaxies, 1% of the galaxies is 10 billion stars, 10 billion stars, sorry, 1 billion stars. 1% of 100 billion galaxies is 1 billion galaxies, sorry, 1 billion galaxies. Let's say just 1 billion galaxies in our vast universe contains planet orbiting around certain stars. And how many stars? Just 1% of the number of stars in that galaxy. So if you multiply 40 billion planets with 1 billion galaxies, you have 40 billion planets. There's a very huge number of planets, much more than the number of grain of sands on, on all the beaches of Earth and all the deserts of Earth. Grain of sands, right? The number of planets, if we take just a very conservative number of 1% of 1%, 1% of a galaxy of 1% of the total number of galaxies in the universe have planets, we have around 40 billion planets. And that's a huge number. And so therefore, right, the assumption is this, the conclusion is this: planets are very common in our galaxy. It is almost being taken as almost all stars, not almost all stars, many stars have planets around it. In fact, the latest planetary, what do you call it, planetary theory states that it is inevitable, it is almost taken that when a star forms, it must be accompanied with a solid body that orbits around it, and that body we can call as planets. So now, if that theory is proven true, then we have just in our galaxy, so the Milky Way galaxy, we have 400 billion stars. Not 40 billion stars, 400 billion, sorry, 400 billion planets. If let's say every single star in our galaxy has just one planet, and we know that is not the case. Why? Because the example is our own solar system. Our sun, which is a star, has at least 8 planets. And when we look out there, there are many stars that have more than one planet. For example, the nearest star to us, which is called Alpha Centauri b, that star has at least 2 planets, which has been discovered, right? At least 2 planets orbiting around it. And so the existence of planets is very common. But how common can you find a planet like the planet Earth, which is habitable, right, with oxygen, and humans can go there and live there comfortably? How common are such planets. And that is what we're going to discover tonight. Now, just to give you a rough idea, the progress of discoveries of planets, and astronomers have been improving their techniques of finding planets, and it's getting easier and easier for astronomers to find planets. In fact, to the extent that the latest technique that astronomers employ, they can discern, they cannot observe directly, but they can discern, they can conclude safely that a planet orbits around a star, and that star is in another galaxy, not in our galaxy. Imagine the distance between our galaxy to our nearest galaxy, Andromeda galaxy, is 2 million light years. Now, this star exists in a galaxy that is further than Andromeda galaxy, and the technique that's been used by astronomers, that they have discovered the first ever planet discovered orbiting around a star, which is in a galaxy that is not ours. So imagine, right, astronomers in the future with better instruments, right, for sure they can find planets, much more planets in other galaxies. And so therefore, it will reinforce, right, the theory that planets are very common across this vast universe. As of now, right, 1st November 2021, there are 4,864 confirmed planets orbiting around other stars. 4,864 planets. Okay. In 3,595 planetary systems, which means that there are some planetary systems like solar system. Solar system is a planetary system. There are planetary systems. The star has more than one planet. So some stars, astronomers have discovered just one planet, but it doesn't mean that it's just one. It can be more, but not detectable right now. But there are stars that astronomers can detect more than one planet orbiting around it. Now, out of that, 803 of those 3,595 planetary systems, 803 of them having more than one planet. There you have it. Now, out of that, 2,234 potential exoplanets candidates. So they have another 2,234 planets that are awaiting confirmation. The astronomers suspect it, that this is a planet. They have a high suspicion rate that there's a planet, but they still need secondary confirmation, means that they need to use another technique to confirm that those are really planets. So these are potential exoplanets. So if you add that 2,274 to 4,864 planets, you get easily 7,000 over planets. Just planets discovered around the neighborhood of our stars, of our sun, actually, right? The stars that are in the neighborhood of our sun, where we can peer directly, right, with our telescope. We can look directly with our vast arrays of types of telescope, using infrared, using ultraviolet, using radio wave, using this and that, whatever instrument that they have, not just light waves, right? They have discovered these planets. So imagine if in the future, with more refined techniques and more advanced technology, for sure astronomers will discover more and more planets further out than our neighborhood of stars of galaxies, and will be hundreds of thousands of planets discovered, maybe millions of planets is going to be discovered by astronomers in the future. Now, this is the exoplanet. Again, the question is, we have thousands of planets orbiting around stars in our galaxy, and in our vast universe, maybe billions and billions of planets. But how many of them, or what is the possibility that any of these planets are like planet Earth? So to do that, we need to find out the requirements to have a planet like our planet Earth. And the most important requirement is what we call as the Goldilocks Zone. And this is the Goldilocks Zone. Okay, the Goldilocks Zone, which is a zone where a planet orbits around its star, and it is just at the right temperature, not too hot, not too cold, just like Goldilocks story, not too hot, not too cold. It's just nice for water to exist in liquid form. If it is a little bit nearer, then the water will evaporate and can never exist in liquid form. If it is further away, then the water will exist only in solid form, in ice. And so the Goldilocks zone is the zone that extends from planet Venus, which is here, to planet Mars. This is called Goldilocks zone. So Earth is in between. So the extreme end of the Goldilocks zone is Venus. If we put Earth and we swap Earth and Venus, and Earth is here and Venus is on the third ring, then we have Earth. Yes, water can exist on its surface, but it's going to be hot. Too hot for humans to live comfortably, or maybe humans cannot live at all. It might be the temperature can be 70, 80 degrees. If you put Earth closer towards the sun, still water can exist in liquid form, but it is very hot for humans to exist. Now, if you put Earth away from the sun and you swap the place between Mars and Earth, and you put Earth at Mars position right now, which is at the extreme end of the Goldilocks zone, yes, water can still exist, right? But it is in very, very low temperature, and most of the time it will be in ice form. The proof, we look at Mars. Mars, when we look there, we can see shapes of, canals, rivers of water, just like we can see shapes of rivers on Earth. Those shapes we can find on planet Mars. So it is, a proof that there exists sometime in the past water on planet Mars that exists in its liquid form, and therefore it flows on Mars surface. Humans have been sending probes over there, space probes over there. So they have been probing planet Mars, and recently one of the discoveries, which of course need to be confirmed by other observations, but one of the discoveries is that there was water on planet Mars, but this water, all of them evaporated to space about 3.5 billion light years, 3.5 billion years ago. So 3.5 billion years ago, right, Earth was still in its Hadean period when it was hot. There was water, right, but water exists in steam form because it was hot. And at that time, Mars was already cooled down to a temperature where it's quite balmy and water can flow on it. But because Mars is very small, right, much smaller than the Earth, and so therefore the gravitational pull of Mars is not that strong, and so therefore all this water, oceans of water might be on Mars surface, they evaporated eventually to space. When they evaporated, right, because of sun's rays, so it became gas. Now this gas, if it is on Earth, this gas will be trapped by Earth gravity, and it will rise to a certain height, certain altitude from Earth's surface. Then after that, it cool down, and then it will go down back as as rain. So it's a cycle. So we not escape to space because Earth gravitational pull it back down, right? But on Mars, because the gravitational pull is weak, and so therefore any water that evaporates becomes gas and will continue to rise and then escape from planet Mars altogether. And so after millions of years, Mars lose its water on its surface. And that is the fate of the Earth also. If let's say we put Earth on planet Mars, right? Of course, we will not evaporate all of them, but most of the water will be locked in ice. Some of it will flow, most of it will be locked in ice. So Allah subhanahu wa ta'ala puts Earth just at the right distance from the sun in a Goldilocks zone, in the middle of a Goldilocks zone, that Earth has a right temperature that animals can exist on it, and eventually humans can live on it with water flowing on it, with 70% covered with watery surface. Is watery surface 70% of it, the ocean 70% of Earth, and so therefore Earth is, from far you can see that the Earth is a blue planet, whereas Mars is a red planet. Why is it red planet? Because there are a lot of ions on it. on the surface, and the ions rust, and the color of rust is red. So therefore, Mars is red in color, whereas Venus is white, really white. The color they can see here is white. Why is it white? Because it's covered in clouds, very thick clouds, and so clouds reflect all the lights that falls on it. So therefore, it becomes white from our perspective. But this zone, right, it has been found that in a star, we call it the Kepler Star, and the astronomers call it as Kepler 186 system. In this system of planetary, planetary system of Kepler, there are a number of planets orbiting around the stars, around that star, that Kepler star. There are, sorry, there are 7 planets orbiting around Kepler. Now, out of these 7 planets, right, one of them, which the astronomer calls Kepler 452, Kepler 186. Kepler 186 and Kepler 452, right, they exist in almost at the Goldilocks zone. Kepler 186 is beyond the Goldilocks zone, but Kepler 452 exists in a Goldilocks zone. Now, it generates a lot of interest because any planets so far before this discovery, astronomers could not find any planets orbiting around a star in a habitable zone, or the Goldilocks zone, which is not too hot, not too cold for water to exist in liquid form. They could not find it until they found this Kepler system, and they found that the planet Kepler 452b orbited around the star, its star, in the habitable zone. So there was, a very keen interest on finding whether water exists on Kepler 452, and if water exists, maybe we can go there, right? If, let's say, we can build a spaceship and we can travel there, if there's a very, very big if, because current technology certainly cannot allow us to travel that vast distance. We'll be long dead before the spaceship reach that system. But unfortunately, this planet, Kepler 452, is bigger than planet Earth, almost more than twice, a little bit more than twice the size of planet Earth. And so therefore, the bigger the planet, right, the stronger the gravitational pull. And therefore, the gravitational pull on this Kepler 452 is twice the gravitational pull of Earth. If, let's say, we have Earth is 1g, this acceleration of gravitational pull, over there is 2g. Imagine 2g is just that, when a jet fighter takes off, right? Now the pressure that is being placed on the chest because it's being pulled back, that is 2g. Sometimes a little bit more than 2g. So imagine, right, somebody living in that planet, they go there, they live on the planet, and most of the time they feel a very heavy weight on their shoulders. I believe in just a short period of time, their shoulders will sag, their spine will be compressed, and they will get shorter, and they will not live longer because their organs in the body will be compressed together. It's difficult for them to breathe, right? The hearts will be squashed between the intestine and also the lung itself, and the liver be squashed, pressure on the kidney. That person will not live long. He will surely die, right? Because human body is not designed to sustain such weight for a long period of time. Will be squashed. So therefore, that really squashed the interest of people who thought that, well, we might go there, because we have destroyed our planet, right? We carelessly destroy the only place that we can live. Well, maybe we can go some other place to live. All the best. You can't go to even this Kepler. Even if Kepler 452 has the same size as Earth, you can't go there because, you know why? Because the distance is very far. It's more than 50 light years away, right? Or is it 20 light years away? Something like that. But it is more than 10 light years away. Even if you have a spaceship that travels half the speed of light, which is impossible, right? It takes 20 years to go there, right? And what about your life, right? And if you factor in Einstein's theory of special relativity, once you reach there, right, the Earth will be long gone, will be, I mean, all your loved ones will be long dead before you reach that system. And then if you have a ship that travels at that speed, which is impossible, we can't build a spaceship that travels at that speed. You said, oh, why not we use warp speed? No, that word warp speed is just an invention of a science fiction story called Star Wars. Sorry, Star Trek. So there's no such thing as warp speed. You can't warp the space-time fabric of you know of this universe, and they say you tunnel through from one space-time to another space-time. Those are just fictional things. You cannot, I mean, it does not even exist actually. Scientists calculated it. It is possible, but nothing has been discovered that points out to the existence of such called wormholes or shortcuts that travels across this universe. It might be out there, we do not know, but as of now, there's no way for humans to travel to even the nearest star. Sorry, not even the nearest star, to even travel humans, not send probes, humans to travel to even planet Mars. There's no way right now. Of course, we are trying to develop that technology, but it is going to be very, very difficult, technically very, very challenging, and humans will suffer a lot along the journey because of the radiation from the sun. And then when they reach, even if they reach planet Mars, right, they will not live long because, like I shared with you, right, the gravitational pull of planet Mars is weak. No water over there. Is very cold and very hot. Sorry, not very hot. It's very, very cold night and day, and it's not being sheltered by all the solar radiations, and therefore people who live on planet Mars will die early because of due to cancer of whatever cancer in the body. So that this Kepler system is one example of all those exoplanets. Again, how can we find a planet like planet Earth? Now, okay, some scientists, right, they try to analyze what make this planet Earth habitable and what are the factors that can give rise to a planet such as Earth, or we call it a habitable planet. And they've come up with three major factors. The star itself must be of certain things, have certain characteristics. The planetary structure of that star must conform to certain things. And then the planet that we want to stay there, we want to be habitable, it must also fulfill certain criteria. These are the three major factors to make a planet habitable. Now, number one, the star. Okay. According to research, right, to have a planet that is habitable for at least humans to stay, to live on it, the star must be yellowish middle-aged stars, like our sun. Our sun is yellowish in color and is middle-aged. How we know it's middle-aged? Because astronomers look at all the billions of stars out there and they have their statistics, and they found out that, you know, according to statistics, our sun of the certain type, of a certain content, it is in middle age. Because for a star like our sun, its lifespan is about 9 billion years. After that, it's going to fizzle out and then it's going to die, right? And now the sun is already 4.5 billion years old. And so therefore, the sun is in midway, is in middle age before its death. And it's yellowish in color. Now, why is important yellowish in color? Because stars have a lot of colors, and the color of the star, right, indicates its age. That's how Allah SWT creates stars, and Allah SWT tells us or informs us or teaches us, right, how to determine the age of the star by looking at this color. If the star is bluish in color, then the star is very young, younger than our sun. If the star is yellowish in color, it is middle age. If the star is reddish in color, means it's approaching towards the end of its life. So therefore, bluish color, it might be, you know, just 1 billion years old, or 500 million years old, or might be 1.5 billion years old, or maybe 2 billion years old, and that's it. So it's quite young. Now, if it is red color, it might be the star has existed for, well, maybe 8 billion years, 8.5 billion years, and that's why it becomes red color. So there are reasons why the colors change as the star ages, right? I'm not going to go into that because it has to do with physics, and it has to do with it's to specifically nuclear physics. You have to understand the interaction between nuclear fusion and those sort of things lah. So whatever it is, right? We know that our sun is a middle-aged star. Now, to have a planet that is habitable like Earth, therefore the star for the habitable planet must be also similar to like our sun, is middle-aged, yellowish in color. Unfortunately, astronomers found out that in our region of galaxy, there are 100 times more red stars than yellow stars. So let's say we have 100 stars we observe, 99 of them are red in color, one of them is yellow in color. If you take 100, right? So it shows what? It shows that if you just take the population of stars, which is red and yellow in color, stars like our sun is just like 1% of the total population of stars in our galaxy. So stars like ours is quite a rarity. There are, of course, stars like ours out there, but they're not many. There are a lot more, 100 times more stars that are dying. It shows that what? It shows that, you know, we are latecomers in the lifespan of a galaxy. All these stars, they have existed before, billions of years before the existence of our sun itself. And our sun is actually, might be, right, probably a second generation star. That's our sun. And all these red dying stars, they are first generation stars. So they will die and they will explode and they will give rise to a second generation of stars. And those second generation of stars, they will be bluish in color, and you have to wait another 4-5 billion years in the future, then they will change it to yellowish color when they reach middle age. And so therefore currently, right, to find a star like us is quite rare. Now that's number one. Factor number two for star to have a planet, a habitable planet orbiting around it, that star must be rich in metal content. What do you mean by metal content? It means that the star must be a second generation star, because a first generation star does not contain any metal. It is pure hydrogen and helium. But a second generation star contains other elements, right? Iron, uranium, oxygen, of course not in its solid form, but it's in atom form. How do we know? Because we can use spectroscopy. This is under physics, right? Allah subhanahu wa ta'ala opens up this knowledge for us. We can break down the spectrum of a star, in fact our sun, and when we break it down, we can see black lines. I've covered this in, I don't know, past lectures. We can see black lines, and those black lines indicate the existence of certain elements in that star. So just from observing the light of the star, we can know what is the content of the star. Incredible, right? You don't have to go there and analyze it straight away by sending probes into the star. Oh, no, you don't have to. You just wait for the light to reach you, and you analyze the light, and you break it down into a spectrum, and you can see all those, you know, black lines on it, and all these black lines correspond, every single black lines correspond to a certain element. So therefore you can conclude that that star, right, contains certain element, this element, that element. Therefore our sun, right, by breaking it down and we can see all those black lines, we know that our sun actually contains oxygen, nitrogen, contains iron, contains aluminium, contains nitrogen, magnesium, this and that, a lot of other. In fact, all the elements that we can find on planet Earth, we can find it in our sun. So it shows that what our planet Earth and all the planetary system in the solar system, from Mercury all the way to Uranus, they share the same content with the sun. They all come from the same source, which is what? The first generation of stars, which produce all these elements. And then when they explode, when that original star exploded, it spewed this content all over space. And then this content, right, all these gases out there, they what do you call it? They fell into their own gravity because they are, what do you call it? Points in space where gravitational pull is stronger because of a creation of mass in there. And so therefore it forms a second generation of star with its children of planets, exoplanets orbiting around it. So they come from the same source. And therefore that's why our Earth, whatever elements that we can find on Earth, we can find it in the sun. Now that sun must be rich in metal content. Unfortunately, again, in a study of 174 stars, but again, I qualify, it's just 174 stars, right? If we study more than that, this thing might change. But in just 174 stars, studied by the astronomer G. Gonzalez, he discovered that none of the stars that he investigated has the level of metal content like our sun. It has metal content, but the level of metal content is low. When it is low, right, the planet that forms around the sun must also be low in metal content. And if it's low in metal content, therefore there is no magnetic field surrounding that planet that shield that planet from radiations from the star itself. Just like our Earth, right? Our Earth has huge metal content. Our inner core, the core of the Earth, is solid metal rotating, right? And around it is liquid metal rotating around it. So therefore, all this friction generates all this, magnetic field, this current and magnetic field. And so therefore, Earth is being protected by this magnetic field, huge, strong magnetic field, protected from those dangerous radiations from the sun. But, if there are stars that are middle-aged, but does not have, all these stars do not have metal contents, just like our sun, if there are planets around it, that planets surely will be bathed with radiations, dangerous radiations, that will, prevent any life to take root on that planet itself. So again, from our, this is limited study, of course, right? It can be, of course, surely will be expanded in the future, but whatever studies have been done right now, it shows that the existence of stars like our sun is very rare. And therefore, right, by extension, the existence of planets like Earth orbiting such stars is doubly rare. So again, right, this is just the beginning. It shows how rare our Earth is. It might be the existence of Earth is just one in a billion planets. It might be that, or it may be just one in our vast galaxy. We do not know. Now, the second major factor is the planetary structure. Again, like I said just now, right? The planet that we want it to be habitable must exist in the Goldilocks zone, not too hot, not too cold. Now, you can reduce the temperature of the star, right? If let's say this planet, right, is a little bit too close to the star, you can reduce the temperature of the star so that this planet's temperature is just nice for water to exist in liquid form. So you have to reduce it. And you can reduce, right? You can reduce the temperature of stars. And there are stars that are very cool, cooler than our sun. Our sun's surface temperature is around 6,000 degrees Celsius, but there are stars out there where the surface temperature is between 2,000 to 3,000 degrees Celsius. So therefore, you don't have to have Goldilocks zone that's further out from the star. You can have the Goldilocks zone nearer to the star. So if there is, any planet that exists in that Goldilocks zone that is nearer to the star because the star is cooler, that planet can have water exist on it. But there's just one factor. The question is, even if you have water on that planet, because it's so close to the star, right? Is the planet habitable? Can creatures live on it? Creatures like us with fragile DNAs and cells, right, live on it? The answer is definitely no. Why? Because the closer the planet is, right, to the star, right, even though it is, it is not, what do you call it? It is not hot, right? But this star is already very old. Is already very old. It means that, right, this planet is also very old. Now, with this planet very old, it exists because this star, billions of years in the past, right, it was still a young star. And then this planet is at that distance, this young star. But then this star, towards the end of its age, it becomes bigger and bigger and bigger and bigger. And so therefore, it gets closer and closer to that planet. And when it gets closer to that planet, it will bath that planet with dangerous radiations, any other fragile creatures like ours that is based on carbon and water. It cannot exist. It cannot live on that planet. It is too dangerous, right? Too radiated by the star itself. Now, if let's say the star is hot, hotter than our sun, so therefore the Goldilocks zone needs to be shifted further away from the star itself. So if any planet that exists on that Goldilocks zone, which is further away from the star, right, that planet might be just have a nice and right temperature for water to exist in liquid form. But again, can life exist on that planet? The answer is also no. Why? Because if it is, if the star is very hot, it means that it is young. It is just 500 million years or 1 billion years old. And so therefore, the planet itself is also very young. And it is so new that there is no time for life to emerge from it. If you're talking from the perspective of natural progression of life, it's a little bit too young, or just very, very young for life to take root on that planet. So if people want to discover any creatures that live out there, and now people have been very exciting talking about unidentified aerial phenomena, or UAP, right? An unidentified aerial phenomena, and all this, you see, all this, they call it phenomena. They don't call it object, because we do not know whether it's a real material object or it's just a phenomena that our science have yet to explain it. There are mysteries out there that our science fails to our current understanding of science fails to explain it. So it might be a phenomena, a natural phenomena, or unnatural phenomena, but not an object. And that is why scientists are very careful. They call it as an unidentified. You cannot identify it. It's aerial, means it's on air, in the atmosphere, and it's phenomena. Okay, UAP. So it can be something, can be anything. But if let's say people say, just for sake of argument, these are extraterrestrials, ET, aliens coming to visit us in a very, very advanced spaceship. Now this ET must also, all these aliens must come from planets. Now that planet must also be habitable. Now if you look at this, right, if let's say the planets exist in a certain distance from a very young star, which is cool, which is very hot, life has not even, there's insufficient time for life to appear on that planet itself. But if it is, if it comes from a planet that has a star that is already cool, which is red giant, it means that that planet is old, and therefore the civilization, even there's a civilization that came from that planet, must also be old, very old compared to our own civilization. So an older civilization like that must possess technology that is more wondrous than what all these UAP exhibits. Right, all these pilots or observers, they saw UAPs, right? They say this is strange, this is beyond our technology. It's a phenomenon. We do not know whether it's real object or not, but it's a phenomenon. It's a UAP. So these possess technologies that's beyond us. But the fact that you can detect it, and the fact that you, ours, humans, right, can actually observe it moving, it means that the technological advance of that, even if that is an alien, the technological, what do you call it, power of that alien does not differ much from our own, right, our own technology. The difference is not that much because we can observe that. But if, let's say, this alien came from very, very much older civilization, much older planet, came from a planet that is already having a red giant or cool star, they might be billions of years old, their technology surely will not be detectable by us. We can't even understand that technology. We can't even know that is a technology. Just like, you know, you have an animal, right, in the zoo looking at us, and we are taking our phone, taking picture of the animal can't even understand what is that thing that we are holding, much less understand that we are taking pictures of them, much less then understand then what picture is all about. So it's very, very mysterious for them. They can't even detect that technology. They will just go about their own, you know, their own ways in that enclosure. So they're not even aware that we possess technology. And that is the difference between animal kingdom and us, right? And that is, you know, just a difference of a few billion years of technology. The mental prowess of animals and the mental capability of humans. Now, if you have a civilization that is more than that, 5 billion, 8 billion years more advanced than us, surely their technology is much, much greater than compared to our technology towards the animal. We are less than the animal, right? We can even detect that technology if, let's say, that's alien. So if people ask me, UAP is the evidence of the existence of, you know, extraterrestrials, aliens visiting us, I would say that's not possible, to put it mildly, right? That is not possible because it's not logical for us to detect their technology. If, let's say, they already have the technology to travel across the vastness of space and reach us, they won't need to even show their existence. Even if they exist among us, we can't even detect them because of the technology that they possess, right? It's beyond our own comprehension. And so therefore, again, it shows that there is no really scientific, logical evidence that all these UAPs are being observed by all those jet fighter pilots belonging to American Army, US Army. They are the aliens that visit us. No, it's not that. Now that is the first factor which concerns planetary structure. The second one is that there must be a giant planet the size of Jupiter on the outer ring of that planetary structure. Why? I will share with you later. And then both of these, the habitable planet plus the giant-sized planet, they must orbit on the same plane and almost a circular orbit. Only then that there is a chance for life to exist or to come or to appear on that planet that you want it to be habitable. Now, why is it Jupiter? And why must it be on the same plane? And why must it be circular? These are the reasons that, inshallah, I will explain when we meet again, inshallah, for our second last session next week, inshallah. So I'll meet you again next week, and let's see if there's any question. If no question, then we call it a night. All right, no question. So thank you very much. We end our session tonight with Tasbih Kafara and Suratul Asr. Subhanakallah bika asyhadu an la ilaha illa anta astaghfiruka. atubu ilaik. Bismillahirrahmanirrahim. Wal 'asri insan fi khusr illa alladhina amanu wa amilus solihat wa tawasaw bil haqq wa tawasaw bis sabr. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.